Okay, so for my video lab presentation, I am going to talk about free fall of objects. So my name is Jared Alonzo, and this video lab is for Physics 221 or Engineering Physics 1. The class is taught by Dr. Azita Fidei at North Seattle Community College. Alright, so the video lab is going to talk about and analyze the effect of gravity with objects undergoing free fall. So a couple of notes here. The motion of a falling object neglecting air resistance is affected by only gravity, and I've shown an image of the motion of an object in free fall, where as the ball undergoes the displacement, the acceleration is constant. An important note here for future experiments, I guess, when you need to analyze the air resistance. Air resistance is very small for heavy objects. So in analyzing your calculations, the small errors in the air resistance is negligible. Also, an important note is that this same law does not apply for light objects such as feathers or cloth. So what I showed here in the image is the acceleration vector is constant, and that constant is gravity, or in this case, negative g. To be more specific, it's negative 9.8 meters per second squared. So for our video lab, we are going to analyze a video that I made physically demonstrating two objects in free fall. After that, we're going to grab and plot the data from the video using the Logger Pro software. And then using the graphs to explain and compare the velocity and the acceleration of each object as they go through the displacement or free fall. And then finally confirm our analysis using the PHET physics simulation online that was talked about in class to show that our data is consistent with the laws of physics. Okay, an important note for Logger Pro. Logger Pro is a free software that is used for data collection and analysis. This is especially useful for analyzing video and graphing the analysis to visual and tangible, or I guess just visual results for you to take a closer look. So this is an image of me attempting to drop two balls at approximately the same height. It's important to note here that in this experiment we're neglecting air resistance, but since the two objects are heavy enough, air resistance would be really negligible if we even considered it. So in the textbook, especially in the free fall section, it states that two objects dropped from the same height will neglecting air resistance will hit the ground at the same time and with the same speed, as I have noted here. And then finally, any two objects in free fall, regardless of their mass, have the same acceleration. Again, some notes here. So the ball on the left is a 6-pound ball, and the ball on the right is a 12-pound ball. So basically, the other ball is twice the mass of another. So we'll go ahead and play a video of this. So again, these two balls are dropped at approximately the same height and at the same time, and the two balls' mass is very different from each other, one being 6 and one being 12. So we'll go ahead and play it. So as you can see, as the balls undergo free fall, they were approximately moving at the same speed, and they approximately, just by visually inspecting it, approximately hit the ground at around the same time. So we're going to analyze this video further using Logger Pro. Alright, so for the video that I just showed you earlier, I went ahead and prepared the data and the calculations in Logger Pro, as you can see here. This little window right here is how I analyze the video, with my height being approximately 1.80 meters or 180 centimeters. And I've gone ahead and plotted the balls as they undergo displacement or free fall, and these are the graphs shown from the data that I gathered from analyzing the video. So once again, I will play the video for you guys to actually see how I plotted them. So it's supposed to actually show you the plotted data points from the video, but I guess Logger Pro didn't show that. But you can tell from here that this is the two objects in motion, specifically this position time graph. So I mentioned earlier that the measurement right here is approximately 180. And since I was raising the balls over or above my head, they kind of went over, so approximately around 210 centimeters starting, or the starting Y position. So as you can see from analyzing data, you can tell that the velocity of the two objects are approximately the same. Again, the velocity is just the slope of the position time graph, and I've gone ahead and plotted these points, the velocity points for you. So by analyzing this position time graph, when the y distance is at 0, or the origin, they are approximately at the same speed, analyzing here, at around, what is this, 0.9 seconds. But as you can see and analyze from this graph, both the objects have pretty much virtually the same velocity as they undergo free fall. So here are my data points for this video lab analysis. So one final thing to note on the acceleration. The acceleration is essentially just the slope of the velocity points. So we can kind of visualize it and confirm that the acceleration is pretty much the same, or the slopes are the same approximately, with this slight error right here. This area, that's just an error in like releasing the two balls at approximately the same time. But like if you analyze these slopes right here, they're almost pretty much identical. So that's pretty much the acceleration of the ball, which is the mass of the ball times the force of gravity. So they pretty much stayed consistent all throughout the duration of their free fall. So a little bit of discussion of the data that we gathered using LoggerPro. So an important note here is that the x motion of the two objects should not be plotted or considered, since there is virtually no horizontal motion as the objects undergo free fall. We're only concerned about the y dimension, or the vertical motion of the two objects. So the two balls are roughly at an equal elevation from the ground when released, and approximately released at the same time. There might be some slight human errors in the process, but the demonstration of the lab is pretty much enough for our analysis. The data points using the LoggerPro are roughly estimated, i.e. I just clicked on some points in the video to analyze the motion of the two objects, and that's really rough, and it's really hard to plot the consistent data points using just a rough point and click method using LoggerPro. And as I explained earlier, when we were in the LoggerPro software, the velocity is essentially the slope or the derivative of the position or displacement of the object, and the acceleration is the slope or the derivative of the velocity. So just by analyzing the velocity graphs, we're able to determine that the slope or the acceleration is pretty much constant for the two objects when they undergo free fall. So lastly, just to confirm our analysis and results from LoggerPro, we are going to be using the PHET or PHET simulation. Alright, so for this PHET simulation, we're going to go ahead and use the projectile motion that is given to us by PHET. And we could kind of use this to analyze the motion of the two objects that we just did in our video, to visually confirm that the two balls will undergo the same acceleration, the same displacement, or the speed of displacement as time goes by. So I went ahead and pre-populated this data. This is essentially negligible, since this is just launching the ball in the air. These are the more important ones though. So for this simulation, we're going to do a cannonball, and the diameter is 1, which the diameter doesn't really matter in this case because we're neglecting air resistance. And then the mass is for this first one, the first object, or the first ball, which is 6 kilograms, but in our video it's 6 pounds, so there's a little bit of differences there, but you could just assume that this is pounds, since this is just a simulation. So I unticked the air resistance variable here so that we can stay closer to our experiment. And then I went ahead and ticked the velocity and the acceleration for this simulation. So we're gonna go ahead and launch our first ball. So again, an important thing to note here is that we're gonna be only analyzing the ball's motion as it crosses this midpoint right here, because this midpoint is essentially when the ball goes free fall. So these are the points, and I guess we could further analyze these points, but this simulation is just to confirm that these exact displacement points and the speeds that we've shown, the acceleration forces that we've shown when the ball undergoes displacement is virtually the same for the two balls. So we're gonna go ahead and do the exact same thing for a ball that is around double it, or I guess in this case it doesn't matter if it's double or not, it's just a different mass. So you can see that the acceleration stays constant throughout the free fall, and these same points or displacements were the same for the two objects. So I guess visually just confirming that our experiment stays true to the laws of physics. So in this video lab, we analyzed a video of the two objects undergoing free fall, and we used the LoggerPro software to gather data and analyze the video further, and by doing that we were able to visually get a closer look on the data points that we gathered with LoggerPro. And again, the errors in the lab execution, i.e. whether it was the same exact height when the two balls were released, and also time for that matter, as well as the graphing of the points using a rough point and click method in LoggerPro should not be a point of emphasis in our I guess calculations and results. The goal was just to show that the two objects, when neglecting air resistance, will undergo the same acceleration caused by only one force, and that force is just the force of gravity. And again, by confirming our findings using the physics simulation, we are able to conclude that all the findings in our experiment are consistent with the laws of physics. So that's basically the end of my video lab, and I hope that you enjoyed it. Have a good day.